Hey guys, today we're going to be looking at proportional relationships and direct variations. A proportional relationship is the same as a direct variation. They have a relationship between two quantities in which the ratio of one quantity to the other is constant. A proportional relationship or direct variation can be described by the equation y equals kx, where k is a number called the constant of proportionality. You can also think of k as slope. So we have the equation y equals kx. You could also think of it as y equals mx. However you want to think of it, just know you could see questions on a test where it says y equals kx, and so I just wanted you to know that k is the same as slope or constant of proportionality. To find k, we can take the y value and divide it by the x value, or k equals y over x. Remember, with slope, we would find the change in y over the change in x. Well, this is very similar. If we know that it's a proportional relationship, all we have to do is the y divided by the x. We don't have to find the patterns. Alright, on this next part, on the left side here, these are examples of a proportional relationship or direct variation. If you notice, both of these examples are linear, meaning it's a straight line, and then both of these examples go through the origin at 0, 0, and you see that point there. It doesn't matter if it's a positive or a negative slope. All that matters is that it's linear and it goes through the origin. Here's what the equations could look like. Y equals kx, which we saw in the definition above, or y equals mx plus 0. The y-intercept has to be 0. Okay, here's examples of not a proportional relationship or direct variation. This first one here, does not go through the origin. It is linear, but it does not go through the origin at 0, 0, so this is not a direct variation. The second one, it does go through the origin, but it's not linear. It's not a straight line, so this is not a proportional relationship or direct variation. Here's what an equation could look like. Y equals mx plus b, where b is not 0. So this y-intercept can be anything except 0. It could be 0.000001. It just cannot be equal to 0. Alright, let's look at these first two here. Are the following examples of direct variation or a proportional relationship? So let's look at this first one. To know whether a table has a constant of proportionality or not, remember to find the k that's equal to y over x. So we're going to take a y value and put it over the x value. So for this first one, it's 1 over 5. And then if we do first number in, last number out, we're going to divide. 5 does not go into 1. Add a decimal and a 0. 5 does go into 2 twice. 5 goes into 10 twice. Let's try the next one. So the next one will be 2 over 10. Divide. First in, last out. 10 does not go into 2. Add a decimal and a 0. 10 does go into 20 2 times. So far, we're getting the same number. We need to keep checking it. The next one would be 3 over 15. First number in, last number out. 15 does not go into 3. Add a decimal and a 0. 15 does go into 30 twice. Okay, we're getting the same number every single time. You have to check the whole entire table to make sure all of them work. The next one would be 5 over 20. First number in, last number out. 20 does not go into 5. Add a decimal and your zeros. 20 goes into 50 2 times. 2 times 20 is 40. When we subtract, there's 10 left over. Add a 0, bring it down. 20 goes into 100 5 times. 5 times 20 is 100 exactly. And then we got 0.25 here. If you notice, the first ones were 0.2, 0.2, 0.2, and then all of a sudden 0.25. Because of this number right here, this is not a direct variation or a proportional relationship. Not proportional, not a direct variation. So it would have to give us the same number every single time when we do y divided by x. Alright, is this next one a direct variation? First thing we ask ourselves, is it linear? And then we ask ourselves, does it go through the origin? Is it linear? Is it a straight line? Yes, this graph looks like a straight line to me. There's no curves or twists or turns to it. Does it go through the origin? Remember, the origin's at 0, 0. Yes, it does. So if we answer yes to both of these questions, it is a direct variation and it is a proportional relationship. Alright, let's look at the last one here. Carly earns $15 an hour babysitting. We're going to fill in the table first. So if Carly earns $15 an hour and she works for 0 hours, I bet she has $0. If Carly works for 1 hour, that would be $15 because an hour means 1 or each. For 2 hours, so if she's working for $15 an hour and she's working for 2 hours, we're going to do 2 times 15, which equals 30. Okay, we'll do the same thing for 3. So 3 times 15 is 45. And do the same thing for 4. 4 times 15 equals 60. Okay, we're going to do the same thing for 9. You notice it kind of skipped a few numbers, which is fine. 15 times 9 is 135. And then for 12 hours. And then add these up. And that's $180. So we want to eventually get to the question, is this a proportional relationship or direct variation? Before we do, I want us to graph these values on the graph provided to the right. So at 0 hours, she has no money. So at 0, 0. And then at 1 hour, she has $15. 2 hours would be 30. 3 hours is 45. 4 hours would be 60. And then it kind of jumps ahead, so to continue this pattern, 5 hours would be 75. And then we're trying to figure out, is this a proportional relationship? I believe so, because it starts at the origin, and then if you connect the dots, they form a straight line. I also know that this is proportional because the table is $15 for each hour, so it doesn't go, $15 for the first 5 hours, and then after that she only makes $12 an hour. It doesn't change any. And if you notice on the table, here's 0, 0, so like this would have to happen for this to be a proportional relationship. So the pattern is constant. It's $15 for each hour. And then it is 0, 0 because at 0 hours she has $0. So yes. If so, what is the constant of proportionality? Remember, that's like our rate of change or slope. It's the pattern that's happening over and over. So we can look at the word problem, and K, the constant of proportionality, is equal to $15 because it's for each hour. And then let's write an equation. Remember, we have y equals kx, where we plug in the constant of proportionality for k. So our equation would be equal to y equals 15x because it's $15 per hour. And then it wants us to predict how many hours will Carly need to work to earn $330. Okay, so we know that she earns $15 each hour. And so we want to know how many hours will it take to get to this $330. I'm going to show y'all with a proportion. Since this is a proportional relationship, we can set a proportion up. And the unit rate, or the slope, or the constant of proportionality, I'm going to throw into the first fraction. I'm going to do money and hours. And we know that she earns $15 for each hour, or 1 hour. And then she wants to make $330. So I'm going to put 330 across from the money. And then to solve for this missing number here, we're going to crisscross multiply. So 1 times 330, which we don't really have to work that out because that's just 330. And then we're going to take that answer and divide it by 15. $15 goes into 33 2 times. 15 times 2 is 30. When we subtract, 3 left over, bring down a 0. 15 goes into 30 2 times. So it would take 22 hours to earn $330. And to check yourself, we could take that 22 hours and multiply it with 15. 5 times 2 is 10, 5 times 2 is 10, 11, add a 0 placeholder because now we're on to the next number. 1 times 2 is 2, and when we add that up, we got 330, so we know that we did it correct. Okay guys, we looked at proportional relationships and direct variations. A direct variation is the same thing as a proportional relationship. So they go hand in hand. Don't let that trick you. It means the same thing. Remember our equations y equals kx, where k is like our slope, or it's really called the constant of proportionality. And then for it to be proportional or a direct variation, it must be a straight line, and then it must go through the origin. Thanks for watching.